In the 1800s, dentist William Henry Atkinson had 3 cases where his patients' teeth exploded. That's right. They exploded. We're going to have to look at the science.
This is a Van de Graaff generator. This belt tears electrons from the bulb. And as it tears the electrons from the bulb, creates a potential. It wants the electrons. And so when I touch it, it takes all the electrons from me and sucks them in. But when you touch the battery, nothing happens. Why is that? What we have here is a salt dissolved in water. And on this side we have copper, and on this side aluminum. Metals have a special property, cell potential. To explain cell potentials relative to copper, I enlisted the help of my dad and my sister. Copper can pull electrons away from iron. Unfortunately for me, aluminum can pull electrons away from copper. Big oof. We would predict electrons would flow as soon as we connect with a wire, but there's nothing happening. However, when we put this paper towel across, we see that electrons flow across. Aluminum ions absorb electrons to turn into a solid, but when they're in solution, they need a salt to balance the charge. Looking at the solution metaphorically as a packing plant, you can see that the salt has to move across in order to get ready for the newly unpacked electrons to move back the other direction. Amperage is the rate at which electrons are flowing by. Voltage is energy, so we can picture it as the gravitational potential energy created by the pull of electrons on a fictional pendulum. In a real circuit, they happen together. You measure the size of a picture in megapixels, and you find that by multiplying the length by the height. But megapixels doesn't tell you the length and the height, so you use aspect ratio. For example, this is in 4:3. If you want to know about amperage and voltage in a circuit, you can multiply voltage and amperage together, and that gives you the power. Or, if you know the power, you can take the aspect ratio, or the voltage divided by the amperage, which is called the resistance. This tells you how much of the power is voltage and how much of it is amperage. So if it's very fat, then it is high voltage. But if it's very skinny, it's high amperage. Yet, they'd have the same power. Here we see 2 test tubes upside down in a beaker. The cell provides 9 volts of electricity. This potential difference allows the water to act as an inverted battery. Our artificial flow allows us to trick the hydrogen into thinking that it's being robbed of electrons by a metal with a more powerful cell potential. This tears the water apart. The resulting hydrogen and oxygen gases collect at the wires. Hydrogen to the negative because it wants electrons, and oxygen to the opposite. Since water is H2O, you see twice as much hydrogen forming on the right. So the mystery is solved. What happened was, he had a false tooth made of 2 different metals with a cell potential between them. And that cell potential caused electricity to flow through his spit. And as it flowed through his spit, it broke it down into its major components of hydrogen and oxygen, which built up pressure in his tooth until it exploded out. So our mystery is solved. But we're going to have to take this into the 21st century. Welcome to the 21st century. We need new battery technology. And the only way to get there is by thinking about the world, looking at the little processes and stringing them together into the new technologies which will save the world.